In this video, we are going to talk about non-parametric tests. So far, we have learned parametric tests. What are parametric tests? Parametric tests have requirement about distribution of the population involved. Well, requirement has to be, let's say, normally distributed, right? It's a requirement for parametric test. Non-parametric test or distribution-free do not require that sample come from populations with normal distributions or any other particular distributions. Okay? So, in the case of non-parametric test, we are doing hypothesis test that does not require any specific conditions about shape of population distribution or value of population parameter. So non-parametric tests are usually easier to perform than corresponding parametric tests. Why is that? Because non-parametric tests have less rigid requirements than parametric tests. They can be applied to wider variety of situations. Non-parametric tests can be applied to more data types than parametric tests. For example, non-parametric tests can be used with data consisting of rank, categorical data, or data that have category, for example, can be genders, can be, for example, survey respondents, okay? Now, non-parametric tests tend to waste information because exact numerical data are often reduced to a qualitative form. So they are adjusted, kind of, sort of. Non-parametric tests are not as efficient as parametric tests. They are easier. Their advantage is that you can apply to any form of distribution. That's advantage. So practically, whenever you can't apply parametric test, you are going to apply non-parametric test. But disadvantage of it is non-parametric tests are not as efficient as parametric tests. So non-parametric tests generally needs stronger evidence, such as larger sample or greater differences in order to reject null hypotheses. Okay, so I would like to make kind of template so we can know we have a table list for non-parametric and parametric tests, which one we are using when. So let me see. Number one, maybe it will be easier to write here. I can write here, it's not a big deal. So first one, when we have matched pairs of sample data, so in the case of parametric test, and non-parametric test. So in the case of parametric test, we are going to use t-test. Okay? Maybe I can change the color here, put here, t-test. In the case of non-parametric test, we are going to use cyan test or we're going to use Wilkinson. We're going to learn this Wilkinson Cyan test. Okay. Next, number 2. Well, efficiency rating of non-parametric tests with normal population. Here, efficiency would be 63% for Cyan test, quality, okay? For Wilkinson, it's gonna be 95%, okay? Next, number 2. What if we have 2 independent samples? Independent samples. In that case, in the case of parametric test, we are going to use t-test. In the case of non-parametric test, we are using Wilkinson rank sum two independent samples. So in the case of non-parametric, we are going to use Wilkinson rank sum test. I hope you can read my scratching. Okay, next one, number 3. When we have 3 or more independent samples. 3 or more independent samples. So for the parametric test, here, so as you can see, it's going parametric, non-parametric. This independent, it's for both of them. Here, this both Wilkinson rank sum test and t-test, it belongs to 2 independent samples. Now, 3 or more independent samples, we are going to use for parametric test. It's going to be F-test, analysis of variance. Analysis of variance. F-test. And in case of non-parametric test, we are going to use Kruskal-Wallis test. We are going to learn all this. Kruskal-Wallis test. Okay. And lastly, I'll write down here, number 4, again for parametric, non-parametric. So when we have correlation, for parametric, we are going to use linear correlation. For non-parametric, we are going to use rank correlation test. Rank correlation test. I would highly recommend to write down and keep it. I don't know if in the higher level, when you get specialized subjects, you might need all this to know which method to apply and when. Okay, now efficiency rating of non-parametric test with normal population. So when we have Wilkinson Cyan test, this is for 2 independent samples. Wilkinson rank sum test, efficiency, it's here. Efficiency is 95%. 0.95. Cyan test I mentioned 0.63. Wilkinson Science test is 0.95. If we apply the non-parametric test with normal population, normal distribution population. Next, Wilkinson Science test, we said 95% efficiency and 91%. Well, Kruskal-Wallis also 95%, 0.95, and correlation, rank correlation test is 0.91. Okay. So once we're done, we will move to study the very first test that we are going to learn, Science test and Wilkinson test. These two tests we are going to learn. Okay. Okay. The Science test. Science test is the type of test. It's a non-parametric test that can be used to test population median, right? Instead of mean, we are using median position. Remember the difference between mean and median? Mean is the average, median is a central position, right? The value of the central position, all right? And we are going to test the population median against hypothesized value K. Okay, so Science test involves converting data value to positive and negative signs. Okay, so, here it is. How to use, where objectives we are going to cover, how to use the Science test to test population median. And then how to use paired sample Science test to test the difference between population medians. Those are for dependent because we said paired. Paired samples are usually dependent. Okay. So, okay, before I move on, let's read the non-parametric test. I already explained all this, but still, let me fly over. So, non-parametric test is a hypothesis test that does not require any specific conditions. Remember, I told you it's a free type of distribution. Any type of distribution can be, okay? And there is not requiring any specific condition concerning the shape of population or the value of any population parameters. Generally, it's easier to perform. Usually less efficient than parametric tests. Stronger evidence is required to reject null hypothesis. Okay. So, Science test, non-parametric test that can be used to test population median, right? Let me clean this. They missed the Science. Okay. I'll add to it, no worries. So if alternative is less than K, then null is going to be greater equal, right? So if right tail is greater than K, the null is going to be less equal. And two tail, if it's equal, then here will be not equal. Okay, we understood that non-parametric test is about hypothesis test of median. Now, what's the difference between them? The Wallis-Kruskal ranking and all the other types of non-parametric tests. So let's start with Science test. That's the first method we are going to learn. So the Science test involved converting data values to positive and negative signs. And I'll tell you how we're going to do it. And then testing to determine whether either sign occurs significantly more often than other sign. Okay, so we already said that sign test is non-parametric, distribution free, we already know, and it's going to use positive and negative signs to test different claims, and these claims can include um, matched pairs of sample data, nominal data with two categories. I already told you it can be two categories. It can be before age 20 and after age 20. It can be genders, I already told you, and claims about median of single population. In all these three cases, we can use sign test. So what is the idea of sign test? We are analyzing the frequencies of positive and negative sign to determine whether they are significantly different, to draw conclusion accordingly. Okay, so this is basic concept. We are going to start assigning positive and negative sign and discard any zeros. How do we gonna do that? So let's say we are testing median. Oh, this is too thick. You see? And let's say we have value k for median. If we have, let's say, less equal, right? 150, for example. So that means all values from database that we will have, whatever would be less than 150, we will put negative, minus. Whatever number data would be greater than 150, we will put plus. But if we have equal, we put 0. But then later on, we will ignore that 0. Okay? That's how we're gonna calculate. So we're assigning positive and negative sign and discard any zeros. Oh, we have it here already. It says here. And then n is going to be equal total number of signs. Let's say n is equal, if my positive ones are, let's say, L, negative ones are M. So n is going to be total number of signs, which means sample size, right? So now let's the test statistics x is equal number of less frequent sign. X is going to be either L or M, depends on which one is smaller. X is equal less frequent sign. Okay. Next, if our the sample data contradict alternative one, then we are going all the way to fail to reject right away. If not, then we are checking if our n is less than 25. If it's yes, we are going to use critical value table. I'll show you. So here is our critical values for sign test. I uploaded where Excel spreadsheet is, so you can download it from there. Okay. So if it's total n is sample size is less than 25, then we're going to use critical value. If it's not greater than 25, meaning n greater than 25, then we are going to use Z table. Okay, and we need to convert Z statistics. X, remember, is the value of less frequent cases, and is a total amount of sample, and that's it. So from there, we are going to find critical value and do a hypothesis test. If the test statistics less than or equal to the critical value, if it's yes, then we reject null hypothesis. If not, then we fail to reject null hypothesis. Here is the template for entire test. Now let's move and start working. This already I talked about it, so I'm going to skip it. You can read. And this one also, let me repeat, X is the number of less frequent signs, and N is a total number of positive and negative. Although I said it's a sample size, but I was wrong because when we have equal to our median, which is 0, we don't put positive or negative, we ignore that one. So my apologies, we can't say it's a sample size. If we have equal, let's say we are testing on 150, and if we have in database 150, then we skip this 150, okay? We are not counting in this N, okay? All right, now let's start. So here is repeating the thought I already mentioned. Let me clean this. If entry is below, we assign negative, right? If entry is above, we assign positive. If it's equal, then we assign 0. Okay, and then we compare positive and negative. So when we already, I talked about it, but so if n is, clean this n, if n is, the test statistics for the sign test is smaller number, if less equal, okay? Here I need to add is less equal 25. The test statistics X for the sign test is the smaller of plus and minus, or minus. When it's greater than 25, then we are going to use z-score table, and we are going to calculate z-score, z-statistics by this method. So X is smaller number of plus or minus, whichever has smaller frequency number, that one we're going to assign to X. Okay, and the sample size, the total number is plus or minus, I would say minus 0, the ones that they have zeros. Okay, we don't count with zeros. Okay, so those are steps we already I already talked about it. Here we need to identify level of significance, which is going to be alpha. Okay. See if anything else is missed here. What do we have here? Oh, those are we already talked. So practically this table 8, it's this table, that critical value for sign test. You are going to use this one. And if it's greater, then you are going to use this score table. We already know. Okay. And here is how we draw decision. If test statistics less or equal T critical, or then we reject null hypothesis. Otherwise, we fail to reject. All right. Next. So here is we have example. Using the sign test, a website administrator for a company claims the median number of visitors per day to the company's website is no more than 150. 1500. Okay. An employee doubts the accuracy of the claim.
So what is important? No more, which is less equal, which is going to be a null hypothesis, right? It includes equal sign. An employee doubts the accuracy of this claim. The number of visitors per day for 20 randomly selected days are listed below. So total, we have 20. At alpha equals 0.05, can the employee reject administrator's claim? Okay. So here is repeating the thought I already mentioned. Let me clean this. If entry is below, we assign negative, right? If entry is above, we assign positive. If it's equal, then we assign 0. Okay, and then we compare positive and negative. So when we already, I talked about it, but so if n is, clean this n, if n is, the test statistics for the science test is smaller number, if less equal, okay? Here I need to add is less equal, 25. The test statistics X for the science test is the smaller of plus and minus, or minus. When it's greater than 25, then we are going to use z-score table, and we are going to calculate z-score, z-statistics by this method. So X is smaller number of plus or minus, whichever has smaller frequency number, that one we're going to assign to X. Okay, and the sample size, the total number is plus or minus, I would say minus 0, the ones that they have zeros. Okay, we don't count with zeros. Okay, so those are steps we already I already talked about it. Here we need to identify level of significance, which is going to be alpha. Okay. See if anything else is missed here. What do we have here? Oh, those are we already talked. So practically this table 8, it's this table, that critical value for science test. You are going to use this one. And if it's greater, then you are going to use this score table. We already know. Okay. And here is how we draw decision. If test statistics less or equal T critical, or then we reject null hypothesis. Otherwise, we fail to reject. All right. Next. So here is we have example. Using the science test, a website administrator for a company claims the median number of visitors per day to the company's website is no more than 150. 1500. Okay. An employee doubts the accuracy of the claim. So what is important? No more, which is less equal, which is going to be a null hypothesis, right? It includes equal sign. An employee doubts the accuracy of this claim. The number of visitors per day for 20 randomly selected days are listed below. So total, we have 20. At alpha equals 0.05, can the employee reject administrator's claim? Okay. Okay, so we have our median. Its claim less equal 1500. That means the median for alternative is going to be greater than 1500, right? Okay, so here is a data created mess, but we still can read it, no problem. Look, all data, every single data entry that is less than 1500, we are going to mark down with negative sign, minus. Greater than 1500, it's going to be plus. Equal, we put 0. Look here, 1469 minus 1462 minus 1633 plus, because greater than 1500, 16 it's plus, 1500 0, and so on. So all these data are placed here, plus and minuses. Now this overlapping here, it's counting 7 science, 7 are negatives, and 12 are positive. So n is going to be equal 12 plus 7 equal 19. Now pay attention, sample size is going to be, if n is equal 19, sample size is going to be 20 because this 0 is not counted in n, right? Okay, so we have amount of negative, amount of positive science. Moving on. So next we have to find, since we have less than 25, right, we are going to use our table for critical value for cyan test. So alpha is 0.05. We have one tail, right? Because it's we had, let me see, right tail, median greater than 1500. Okay, so how much is going to be critical value? 0.05. From here, it's one tail. We are coming down, and 19. That's what we got, right? Here, 19. See? With this 19, our critical value is going to be 5. Okay. Next our step is going to be test statistics. Our test statistics is equal 7 because we have 12 and 7, right? Out of 2 counting informations, we are going to take a less frequency 7. We had 7 and 12, right? So we are taking 7. Using smaller number of plus or minus. And what do we say? Because our x, that is equal 7, and our critical value is equal 5, right? Which means our test statistics is greater than our critical value, and that means we fail to reject null hypothesis. And which is our claim, right? Null hypothesis was our claim. Yes, null hypothesis is our claim. So we're going to draw conclusion about null hypothesis. So from here, we can say that since we failed to reject null hypothesis, that means we accept it, right? And because we are going to use the verbiage reject, we have to add another negation. So with the word reject, will meaning would be support. So at the 5% level of significance, there is not enough evidence for the employee to reject the website administrator's claim that the median number of visitors per day to company's website is no more than 1500. Okay. Next one. An organization claims that the median annual attendance for museum in US is at least 39,000. A random sample of 125 museums reveal that the annual attendance of 79 museums were less than 39 and 100,000, and the annual attendance for 42 museums were 39,000. At 0.01 significance level, is there enough evidence to reject organization's claim? Okay, so this is our claim that median annual attendance is at least 39,000, at least meaning greater equal. So our claim, yet again, is going to be our null hypothesis. So here we have 39. This is, hold on, it says at least, no? An organization claims that median attendance for museum is at least 39. Okay, now the question is there enough evidence to reject organizational claim? Okay, but our claim is this one. This is wrong. Claim is greater than 39,000. This is going to be our claim. Okay, so what we are going to do in this case, it says 79 is with negative sign, 42 with positive sign. How did we figure it out? It's because here it says 125 museums reveal that 79 museums were less than 39,000. Therefore, 79 is marked with negative sign, and annual attendance for 42 museums were 39. At least should be 39. Otherwise, we shouldn't put plus. Okay. So 79 is going to be negative sign and 42 is going to be positive sign. So and together it's going to be 79 plus 42. It's going to be 121. Now, because sample size, n is greater than 25, then we can apply z-score. Oops. We can apply z-score table, right? Because n is greater than 25. We can apply z-score table. Okay, so let's figure out our z-statistics. Our z-statistics formula is, here it is, so I can write down also one more time. It's not a big deal at all. So z is equal x plus 0.5 minus 0.5 times n, 121, right? And we divide by square root of n divided by 2. This is going to be our z-statistics. So we're applying 42 plus 0.5 minus 0.5 times n, which is 121, and divide by square root of 121 by 2. And we get negative 3.21. Now, critical value. If you go to z-score, and obviously since alpha is 0.01, which is less than 50%, because this is 1%, you are going to check a negative z-score table. And if you look in the middle, just refresh your memory, since alpha it's a percentage, so we look in the middle, 0.01, and you should come here negative 2.33. Here it is, negative 2. Our critical value, negative 2.33. And if we compare to our z statistics, negative 3.27, you will see it's falling in rejection area. So we are going to reject null hypothesis and claim that and draw decision that at the 1% of significance, there is enough evidence to reject the claim that the median annual attendance for a museum is at least 39,000. Okay? Okay, I am done with this topic. Moving to next one.